All right, good afternoon, students. Please, I want us to look at this experiment on simple pendulum. This is experiment 2. The aim is to determine the acceleration due to gravity and height to a ceiling. So if that is the case, you can look at this diagram. The distance from here to here is a floor. So this experiment can be done in two ways. One is that they can use a record stand to represent this. And when a record stand is used, we get a different reading. Another one is that they can hang this thread on the ceiling. And from here to this point is a floor. So they will not ask you to measure either 20 centimeter height of this. Like look at what is here. They said by height, 20 centimeter as shown in the diagram. Are you with me? On the position of the displays. Then we are asked to obtain our readings. Now, when you look at this, it says plot a graph of h against t squared, determine the slope, determine the intercept, evaluate k, which is equal to this. Now, look at this. I want to use a particular reading to show you this is the reading I want to apply. Let me use this, my reading now. This is the reading I want us to apply, this reading. When I did this experiment, I got this reading. So if this is what I have, I want to use it and plot. But one might ask us, how did I get this? Okay? One may decide to ask that question. Yeah, you can get this thing from this particular formula that T1 is equal to 126 times square root of 3.7 minus h in meter all over 10. This is the formula I will use if I want to get this reading without performing the experiment. Like the first one, T1 is 126 times square root of 3.7 minus this h here is this one, which is 0. What? This one is 0.2. So I will come here and put 0.2 divided by what? 10. So when you solve this, you get 74.54. You come and write it, okay? Then for you to get your T2, you will vary this. If this is 74.54, you can decide to say 74.59. You change this thing, plus or minus. You can either decide to add or you subtract up to 5 points. Okay. So let me use this my reading now and make a graph. Let me use this reading and make a graph. Look at this. This is my graph. I have this graph as first thing I will do is to come and draw this line. I am going to draw this line. If I draw this, we get this point now. Then take another one, draw it this way, then take these points. Okay? Then on this axis, you write H, open a bracket, make sure it is M. On this axis, you write T squared, put X squared. Now, what is the scale on the vertical axis? The scale on the vertical axis shows that 2 centimeter represent 0.2 units on H axis. Now, in physics, we don't say represent something unit on the vertical or horizontal. We use what is here. This is H axis, okay? And then for the horizontal axis, if you watch on the horizontal axis, you see what I have here is 10. This is what? 10 point what? 5. This is 11. Now, that does not mean that it is 2 centimeters to represent 10 units. No. Look at this. You see this zigzag look at this very well. You see it. Now, this thing implies that there are some other points that is behind this particular 10, okay? But then the point tends infinity. So I will use this to connect those points. Then if here is 10, I have 10.5, 11, 11.5. What it means is that I am using 2 centimeter to represent 0.5 units on t-squared axis. Now, how do I plot this my graph? If here is 10, here is 10.5, okay? It means that the distance from here to here is 0.5. So when you divide it by 10, if you divide this thing by 0.5 by 10, you will get 0.05. So each of this block now is 0.05, right? So here is 10.05, here is 10.1, here is 10.15, here is 10.2, here is 10.25, 10.3, 10.35, 10.4, 10.45, 10.5. Now, that is just it. So the easiest way you can remember this is that 2 blocks is 1. So if here is 10.5, here is what? 10.6. Here is 10.7. Here is 10.8. 10.9. You see 11. Okay. So let us make our plot now. When it is 13 point, when it is 13.8, I'm going to plot, I will use 13.9 now. I will approximate this to make it to be 13.9. Then it is 0. What? 0.2. So look at my graph. This is 13. This is 13.5. Okay. This is 13.6. 13.7. 13.8. 13.9. Trace it. This 13.9. Trace it up. You see this point now. Connect this point with when it is 0.2. When it is 0.2, connect this thing. When it is 0.2, connect this thing, you get it. Now the next one is 13.01. I am plotting 13.01 here against 0.4. So you have 13 point, this is 13.1, right? This is 13.1. What I'm looking for is 13.1. 13.1 here, right? We'll come to the graph. This is 13. This is 13 point what? 1. This is 13 point what? 1. So if here is 13.1, now trace it. Trace it up. This is 13.1 already. And this point is 0. What? Take it. If you trace it here, you get 0.4. Okay? Now, get to the next one. This is 12.3 is what I will look for. 12.3. Due to the nature of this graph, 12.3 against what? Against 0.6. So watch. This is 12. This is 12 here. If here is 12, here is 12.1. Abi? This is 12.2. And this point is 12.3. So trace this 12.3 and then connect it with 0.6. So this is exactly what you are going to do until you get a graph that looks like this. This is the nature of the graph, okay? Then from this graph, we need to find our slope. We need to find our what? Our slope. We need to find our slope. So the slope here is equal to, the slope is equal to change in, the slope is equal to change in h, in meter, put the unit, over change in t squared, put the unit. So which means that my slope is now equal to, trace this one, you get it to be what? Look at this point here. This is 0.9. If this point is 0.9, this is 0.92. So it is 0.925. So we say 0.925 minus, look at, this is what I have as 0.925 here. Then minus what? Trace this point also. If you trace this point, you have it to what? To be 0. What? 0.3 all over. Now, this point is, look at this point. This is a negative graph. So you need to write this one first of all, which is what? 11.0. This is 11.0. Look at it here. If you trace this thing, you will get 11.0. And then this one is what? This one is 13.5. You get it? 13.5. That's what I'm using. This is 13 point what? Minus 13.5. So when you do this, you get your slope to be equal to minus 0.25. And then put the unit, which is meter per second what? Square. This is exactly my slope, okay? That is my slope. Then the next question says we should determine the intercept. The intercept. Now look at the intercept. Look at this graph. If you look at this point, this is 1.3. This is 1.2, 1.3, and this is what? 1.4. So the intercept is here, which is exactly 1.3. So I will come and write my intercept is equal to 1.3 meter. That is my intercept. You have to put the unit of the intercept also. Okay, good. The next question says we should evaluate k, which is equal to minus 4 pi squared s. So therefore, my k here is equal to what? Minus 4 times pi is 3.142 or squared, right? Times my slope is minus 0.25 meter per second square. So when you do this, you have your k to be equal to what? 9 point. You're going to have, press your calculator, you have it to be 9 point what? 87 meter per second what? Square. This is the value of my k, right? This is my k. So the next question says we should find the error in k. Okay, so use this solution. Error in k is equal to error in slope all over slope multiplied by what? By k. Then always put plus or minus. Okay, Now, we already know our slope. We know our K. But we don't know our error in X. So we know that error in S is equal to 4W over NR. Now, in this case, my N is equal to what? 5, which is the number of plotted points. Which is the number of plotted points, okay? And then what is my W? My W is equal to, if you check this particular graph, look at this graph. Look at this graph very well. Look at this graph very well. You see where I did small thing on my what? You see where I did small thing here. You look at it. See, it's very, very tiny. This is my vertical scatter. This is my vertical scatter. This is my vertical scatter. This is my vertical scatter, okay? Then if you trace this vertical scatter, trace it. You see this point here? See this point? You see this point, right? You see the 2 points now. Means that from those 2 points, we have that my W is equal to 0.76 minus 0.72, which will give me 0.04. Okay, that is a vertical scatter. And the unit is what? Meter. Now, my range. How do I get my range? How do I determine my range? This is this point here minus this point here, okay? Trace it down, these 2 points. But we can easily get it from the reading, which is the highest value minus the lowest value, which means that my range is 13.8998 minus 10.7338, which will give me 3.16. Now, this is my what? This is my range. Okay, I've gotten my range, and this is the unit. Now, if I've gotten my range, I've gotten my vertical scatter, we can now find our error in what? We can find our error in what? Let's get our error. So therefore, error in S is equal to 4W over NR, which will give me what? 4 times what? 0.04 all over NR, 5 times 3.16, which will now give me 0.01. So it means that the error in slope is 0.01. Therefore, error in slope is 0.01, right? Then the unit is this. This is the unit. This is my error in slope. So we need to find error in K now. Error in K now is equal to error in S all over S multiplied by K, plus or minus. So error in K is now equal to, error in S is what? 0.01 divided by the slope, which is what? 0.25 multiplied by what? My K, which is 9.87. So if you use your calculator now and press this, if I use my calculator and press this, I will get that 0.01 divided by 0.25 is equal to this. Multiply it by 9.87, which will give me 0.39. So this is my error in K. And then it will carry the unit of my K. And the unit of my K is meter per word per second. So this is per second square, sorry. This is the value for the error in what? Error in K. Okay? This is the value for error in K. And finally, we are asked to solve this. The question says, is a spherical ball preferred in this experiment? Why is a spherical ball preferred in this experiment? Look at my answer here. I said, why is a spherical bulb preferred in this experiment? The answer I gave is, a spherical bulb is preferred because it has a uniform distribution mass and the air friction